So welcome to this short presentation of SiLift, which is a difference tools for models, and especially the aim of SiLift is to produce differences that are on the level of user edit operations. So to demonstrate the tool, we will switch around a bit between the perspective or the role that an end user, a comparison tool user has that uses SiLift, and a tool engineer that configures SiLift for any specific modeling language. So we start now with the perspective or the tool environment of the tool users, and we assume here that a tool user has a base revision, which we call A here in this demonstration, which is a simple class diagram, and we assume further that this class diagram gets edited to become a revision B. And as you can see here, we have made basically two changes. First, the navigability of this association works for is restricted to the end of the person, and you can look here, it's navigable in both directions. And these two name attributes are pulled up to the person class, which is the common superclass here of developer and manager, and now gets inherited to both subclasses. So now a user wants to compare what has changed between revision A and B, and for that we select the UML models, and we have here a context menu, semantic lifting, and we compare these UML models with each other. Now this dialog of SiLift has some configuration options. We can here select the matching engine, which is used in the first processing step to compute the correspondences. We provide here an adapter for EMF compare matching engine. This should be enough here in this case, and we can use the semantic lifting algorithm here. And in the first step I select here no semantic lifting, so that we can see what the result is if we do not use semantic lifting for the comparison of our two models. Now we finish and we get here a difference. We call it technical difference because it contains only low-level changes which describe the changes from A to B in terms of the abstract syntax graph, because what we do basically is, of course, we do an abstract syntax graph comparison. This is what comparison tools usually do for models, and so you see here that we have a lot of low-level changes which are simply not understandable for tool users that are not familiar with the internal representation of the model. And so what we really want is to lift this operation or to produce a difference that is on the level of the user edit operations, and therefore we start another comparison with some modified parameters. So the matching engine can be again EMF compare, and now we say that we use our semantic lifting engine to lift the differences, and the semantic lifting engine needs recognition rules which are looking for patterns here in the difference that constitute then the invocations of the edit operations. And so for now there's only one rule base provided, which is called UML2 atomic, and it contains basic edit operations for UML class models, and we use the recognition rules which are generated from these basic operations to lift now the difference. Now let's see what happens. We get another difference output here. I close the older ones. So now we can see that all the low-level changes we obtained in the former run are grouped here to semantic change sets. And yeah, what do we group, or what does the algorithm group? It groups low-level changes that constitute one conceptual edit operation. And to get a better impression of these differences, we open here our comparison viewer, and there you get on the right hand side then highlighted the elements which are the context of one edit operation that has been recognized by the lifting engine. And so what we see here is that with the configuration option UML2 atomic, we get here 4 change sets. So actually 4 edit operations are reported. And the first one is a move here from the property employer to, from the association. It was formerly contained by the association and is now contained, it was contained by the class person, excuse me. And it is now contained by the association, so it is not navigable anymore. Another difference that we see is that one property, here this property name of class manager, is simply deleted. And here we call this a pseudo difference because this is the unsetting of the type of this deleted property. And the next difference is a move here from this attribute name to this attribute person. So as you can see now, the difference is quite better, but there are some things that are not that optimal, because actually we do not want to have reported here a move from a property from a class to the association, because it is, from a user's point of view, it is navigability restriction. And of course it would be great to have these 3 change sets further grouped to a big change set which reports that the refactoring pull-up attribute has taken place here, and this name attribute has pulled up to class person. So now we switch to the perspective or to the tool environment of a tool engineer, and we want to configure recognition rules and edit rules so that this refactoring can be recognized. So now we see here the tool environment for a tool engineer, and what a tool engineer basically has to do first is to specify edit rules that implement the edit operations, the complex edit operations that shall be recognized later on by the comparison lifting engine. And so I've provided here already these edit rules for our refactorings. First of all, here these are Henshin transformation rules, which are based on graph transformation concepts. And I'll show you here the edit rule for, we can start with a restrict navigability in this integrated Henshin editor. And we see here on the level of the abstract syntax tree or abstract syntax graph, this is basically this movement of a class to the association. This has been recognized, but now this should be, of course, recognized as restrict navigability. And the pull-up attribute refactoring, which is a bit more complex and uses amalgamation units of EMF Henshin. So this amalgamation unit here consists of a kernel rule, and the kernel rule states that we move here a property from a subclass to a superclass, and this should be done only once. And Now the kernel rule here is embedded into the multi-rule, and the effect of the multi-rule, which is a deletion of a property with exactly the same name and the same type, shall be applied as often as possible if this context here, which is matched by the kernel rule, is fixed. So this is basically the implementation of the refactoring pull-up attribute. And now these are the edit rules, which implement the edit operation, but what we need are the recognition rules. And for that, the tool engineer creates another project. So I have already created here a project stub to save some time. And now what we do here is that we need to specify a rule base. We've provided here a simple wizard, a rule base wizard, and here we have to give a name to our rule base, so I call it just UML2 complex. Now we have to select the edit rules from which the recognition rules shall be generated, and these are the ones here in our edit rules complex plugin project. So I select the folder. Now these edit rules are contained in our folder. We can select all here to generate recognition rules. Press finish. And so now we see that we have here some recognition rules generated from our edit rules, and basically this is all a tool engineer has to do. One configuration option here is to specify property values for recognition rules in case of two recognition rules lead to exactly the same set of low-level changes, which is an ambiguity, and this may happen here for restrict navigability and the atomic operation move property from class to association. So we want to give a higher priority here to restrict navigability, because we want to have this recognized as navigability restriction, and just save now the rule base. So now usually you're gonna deploy these plugins into the environment of the tool user. To save time, I just start here an Eclipse application, a new instance from this running Eclipse, which contains then all these plugins here in the workspace. And so we switch back now to the perspective of the comparison tool user. So I first want to close here the old editors, and we start a new comparison run here between A and B. Semantic lifting, compare with each other. So of course the matching engine stays still our EMF compare matching adapter. We use our recognition engine, and now that you see here in this rule base window, we have here another rule base, UML2 complex. This is the one that we have just created in the role of the tool engineer. And of course we want to include these recognition rules now in our comparison run. Finish. Now we got a new difference file here. You see here now we have two semantic change sets, and I arrange now here this comparison view again. So you see here we have Now one change set, restrict navigability, which reports now the edit operation that restricted here the navigability of this association end. And we have also recognized here the pull-up of these attributes name to the common superclass person. Yeah, so that's basically the tool environment of SiLift. To summarize and conclude, what have we seen now? We have seen that a comparison of models on the level of the abstract syntax graph leads to low-level differences and to low-level changes that are simply hard to understand for normal tool users, and which must be semantically lifted to invocations of user edit operations. And SiLift provides here tool engineers with the option to configure the lifting engine for any modeling language, and tool users are finally provided here with this difference viewer, which can be used to interactively inspect then the differences on the level of the user operation. So you find further information on the homepage of this project. There is also a download option for the tool, and yeah, feel free to try it out, the first prototype. There's an Eclipse update site, and if you have any problems, don't hesitate to contact us. Thank you.